Yeah. And if you look, again, this is one that you have to memorize, as is y equals ky, dy dt. To get from here to here, we can separate and integrate. Okay? I'm not going to do it right now. So you would have to multiply both sides by, I would probably distribute actually, yeah. I'd probably distribute first, and then move, and then all sorts of stuff. It's a lot easier just to say, hey, I can go from here to here, and I'm okay with that. I just need to understand where things are located, and how to figure out where carrying capacity is. Because sometimes I can give it in that form, and sometimes I'll get it in this form.
So we should really know both.
Yes. You don't have to go from one to the other. You don't have to show me how to do it. You just have to recognize both forms. Okay, they're the same. Well, that's the rate of change, and that's the actual formula for the original. Sure. So here we go. Again, L is not carrying capacity. K is still some constant of proportionality. So notice that on my differential, K is sitting underneath the function. Over here, K is sitting on top. Notice that the formula here says 1 plus A e to the kt, or 1 plus c e to the kt, negative kt. It's a negative there. Yeah. That negative is important.
Is it supposed to be a derivative? Or is that a
This is the function. That's the derivative.
No, because like by the t, there's like a thing. Well, I don't know if that's like a
That's comma. Okay. This is a comma.
It looked like the integration.
So let me fix that. That's a comma sign. So if you don't need to, so you may want to cross that out. That's a comma sign. That's not a prime sign. It's a good question. It's not a prime sign. That's a comma sign. It's not a derivative sign. Yeah, it's a comma for the actual sentence. All right. So I have this. Y equals 200 over 10 plus 30 e to the negative 0.01 t. This is a logistic approach equation. Does this look like the one that I gave you?
Yes.
Vaguely.
Vaguely. Jack, why do I need to divide by 10? It needs to be 1 plus.
I agree.
Jack says that I need to be 1 plus, because my formula says 1 plus. So if I divide by 10 on the top and divide by 10 on the bottom.
This is for only part A though, or in general?
That's just in general, because my formula is 1 plus. So I divided by 10, that gives me 20, right?
Agreed.
This gives me 1 plus what?
3.
3. E to the negative 0.01 t.
And then you just lie.
So, what is the initial population?
Wait.
How do I... No, initial population is not 20.
3.
And it's not 3 either.
You have to plug in 0.
Thank you, Tiffany. You have to plug in 0 for t. Initial population means when you plug in 0 for t. 20 over 1 plus 3 e to the negative 0.01 times 0. 1 plus 3 times 1, or just what?
4 over
5.
What's my initial population of whatever this is? 5. I have 5 dogs, 5 bacteria, whatever I'm talking about, 5 deer, 5 people. I have 5. Plug in 0 to get an initial population. What is the carrying capacity for this thing? The L.
20.
By the way, that's like the max population that can carry it be sustainable.
How many doses?
What is the value of K?
Negative 0.01.
Please don't lay someone that is not negative.
Why?
Because the formula is e to the negative kt.
Oh.
The formula is e to the negative kt. So K is not negative.
So is this in this equation if it was positive then?
Correct. If my equation said e to the 0.01 t, then K is negative 0.01. The what? There'll be the K would be positive. When does the population reach half of its carrying capacity?
So when does it reach 10?
Yeah.
So when is the equation equal to 10?
So 10 equals.
What do you want to do? Nope, I'm not going to do by calculator. I want you to do the work. Okay. So you have a variety of things. You can multiply the bottoms over. You can flip it, either one. I'm going to multiply the bottom over, so it's going to be 10 parentheses 1 plus 3e to the 0.01t equals 20.
Oh, you can
Negative,
flip it and
thank you.
then cross multiply?
You can, yep. So it's flip them cross multiply. Same thing as this.
Oh, then divide by 10.
Because it's half of the carrying capacity. The question says, when does it reach half of the carrying capacity? My carrying capacity is 20, so half of that is 10. I am going to divide by 10 because it's just easier. So 1 plus 3e to the negative 0.01 t equals 2. 3e to the negative 0.01 t equals 1.
And then it's negative 2.
What do you do after you divide by?
No, you need to get e by itself before you do ln. Now I can do ln. Natural log of 1/3 equals negative 0.01 t.
You divide by negative.
So natural log of 1/3 over negative 0.01 equals t. Natural log of 1/3 divided by negative. 109 point stuff. I like that. That's good.
It doesn't say.
13.
It doesn't say.
So I'm gonna just put time. Because I didn't give you units. Yes. Alright. Find the initial value problems whose solution is y of t. Find the initial value problems whose solution is y of t. So again, ladies and gentlemen, let's think back to what we started with. The very first one that we did with exponential growth in decay was an initial value problem. What did I say you had to have? A derivative, a dy dt. And
We have the initial value.
the initial value. So let's start with initial value. That's easy. What's that?
0.
So y of 0 equals 5. There's my initial value. Now let's talk about dy dt. Ladies and gentlemen, on the front page of your notes,
KY.
it says dy dt equals ky times 1 minus L over y, or y over L. Does it not?
Yeah.
Do I know what K and L are?
Yes.
Yeah. K is 20.
K is not negative.
That's all you have to do.
Did it say to solve this? Or did it say write the initial value problem whose solution is this? Again, ladies and gentlemen, read. 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 It's good for you.
That's why they built in that 10 minutes.
That's why they built in that 10 minutes.
We're gonna read calculus.
That's why you're going to read calculus.